All right, so Module 7, 7.0a review. We're going to be looking at area of triangles and quadrilaterals. So it's really important to understand that all shapes in this entire module are not drawn to scale. Okay, you need to go by what they're labeled as, not by what they look like. Okay, all right, area is the amount of space inside of a shape. It's measured in square units. Okay, so we're going to look at some different shapes when you cut them up and rearrange pieces. Okay, the area doesn't change. Okay, so let's look at area of a triangle. So we're going to take and we're going to cut these pieces out, and we're going to tape the shaded triangle below, and we're going to tape the unshaded triangle below. That's exactly what I did already here, just to save a little time. Okay, so using B and H, what is the formula for the area of the entire rectangle? Okay, so the entire rectangle, you're going to take area equals B times H. How do you identify the base and the height of a triangle? They both come together at a 90-degree angle in the triangle. Okay, so this B and this H come together at a 90-degree angle, and so does this. Okay, up here in the rectangle, you're just going to use B times H. Okay, if this is H, this is H, and this is H, isn't it? Just like it shows here. All right, what is the relationship between the area of the shaded triangle above and the unshaded triangle above? They are the same areas. What is the relationship between the area of a shaded triangle and the entire rectangle? Okay, I hope that you can see that this entire thing is half here and half here. Okay, so the shaded area is half the entire rectangle area. So here's your formula for the area of the shaded triangle. We're going to take half BH, or you can do it as base times height divided by 2. Same thing. Okay. All right. Next thing we've got is a parallelogram. We're going to cut out the parallelogram and we're going to rearrange it to form a rectangle. Okay, and we know from the prior page the formula to find the area of a rectangle is base times height. Okay, how do you identify the base and the height of a parallelogram? They both come together at a 90-degree angle in the parallelogram. Okay, so it's super important to understand this is not your height. This is your height because it comes together at that 90-degree angle. Use base and height. What is the formula for the area of a rectangle? It's just area equals base times height, just like it was in the rectangle on the prior page. What is the formula for the area of the parallelogram? Base times height. Okay, for a trapezoid, this one's a little bit more complicated. So we're going to cut out those pieces. It says cut along the solid lines, not the dashed, rearrange and tape to form one triangle. So basically I cut this piece out and flipped it around and landed it here. Okay, so it's really important to see base 2 and base 1. A trapezoid has 2 bases. Okay, so you can see this whole thing is base 2 and this is base 1. Okay, the sides that are not the bases of a trapezoid are called legs. Okay, so these are the bases. This is a leg and this is a leg. How do you identify the bases? They are the 2 sides that are parallel. So these 2 sides never cross each other if they're extended. Those are the bases. You know that these aren't because if you extended them, they would cross up above there. How do you identify the height? A base and height come together at a right angle. Okay, so again, this height right here comes together as a right angle here. It also comes together as at a right angle right here. Okay. All right, let's start building the formula for a trapezoid. Using B1 and B2, what is the base of the triangle formed? Well, the base, this whole base, is base 1 plus base 2. What is the height of the triangle? H. and then the formula for the area of this triangle. So we're going to do area is a half. The base this time is B1 plus B2 times H. So that's your formula. The formula for the area of a trapezoid is a half. Add the bases together times the height. Okay, now we've got some to practice using those formulas. Let me get the right page over there. All right, find the area of the following figures, round answers to the nearest tenth where applicable. All right, so we've got a parallelogram here. So area equals base times height. Okay, now do you understand that if this is 10, this is 10, and if this is 7, this is 7? The height is 4. Okay, so we're going to be using this height of 4, and where that comes together as a 90-degree angle here, this is the base. So this is also 10. So we're going to have 10 times 4, which is 40. So 40 inches squared is the area of this shape. Okay, this guy, we're going to start with the formula, half, add the two bases together, times the height. Okay, now you know the bases of this are 12 and 6 because they run parallel to each other. They would never crash if they're extended. The 5 and the 4, if you extended those would crash way up here. Okay, so let's start plugging in some numbers. 6 and 12 are our bases, and our height is not the 5. The height comes together at a 90-degree angle, so it's 4. So we've got 1/2, 18 times 4, and that would come out to be 36. So 36 meters squared is the area of this trapezoid. All righty, number 18, triangle. Area of a triangle is 1/2 base times height. Remember, the base and the height are where the two sides come together at a 90-degree angle. So we're going to be using 4.5 and 6.3, not the 7.7. Doesn't matter which one's which, B and H. Remember the commutative property of multiplication. It doesn't matter if you multiply them this way or this way. It's the same thing. Okay, now using a calculator was 14.175. I did that prior here. Now it said around to the nearest tenth where applicable. So we're going to have 14.2 feet squared is our answer. All right, number 19, trapezoid. 1/2, add the two bases together times the height. So 1/2. Okay, the bases are the two sides that are parallel, 5 and 7.5. The height is not the 3.9, not the 4.7, it's the 2.3. It's where it comes at a 90-degree angle to the bases. So if I do all this out, it comes out to be 14.375 rounded to the nearest tenth. It's 14.4 feet squared. A couple more on the back page. Okay, sometimes the height of a triangle is drawn on the outside of the triangle. Okay, so the solid black lines are the triangle, but those dotted lines show the height. Okay, so we've got a triangle, 1/2 base times height. Okay, now it's very important to understand the base is the side that comes to a right angle with the height. This may look like the base, but is there a right angle that goes to it? No. Okay, so our base is really 3. Our base is really 3. I almost wrote the 3 there. This should be a 1/2. So 3, and then 2.8 is the height. Okay, now if you pop that in a calculator to the nearest tenth, it comes out to 4.2. So 4.2 meters squared is our answer. This guy, base times height. All right, what numbers are we going to use for a parallelogram? Remember, the base comes to a right angle with the height. So this 5.9 is going to be the base. Okay, you don't count this dotted line. That's not part of the parallelogram. It's just there to show the height. So 5.9 times 4. And that came out to be 23.6. So 23.6 inches squared is your answer. Okay, so these really should have been a review of elementary school. Maybe the trapezoid might be new, okay, but you really should have had some experience with area of a parallelogram, rectangle, and a triangle. Okay, thanks guys.